Hello, my name is Paul Turley. I'm a principal consultant with Pragmatic Works and a data platform MVP with Microsoft. There are some methods you can contact me with questions. You're welcome to reach out to me, and I will link with you as long as you're not trying to sell something. So we're going to talk about new features in Power BI specifically designed for managing large-scale, serious, IT-driven and managed solutions with Power BI. This presentation was actually prepared for a live presentation at our local Power BI user group meeting, which was canceled due to a snowstorm that didn't occur. And the pop music references were there to incent participation. And there were prizes for correctly guessing the artists of the songs that I referenced. So just for fun. What's this all about? We're going to talk about BI models, the way that we did serious data modeling in the past and today, and where that's going in the future. We'll talk about some new, both evolving, emerging, and some existing Power BI enterprise features, which includes different modeling choices, how the design tool features are merging and where that's heading over time. We'll talk about working with data at large volume, high volume, and massive scale. And then I will show you as a reference project, which is a real project that I worked on recently, and actually using screenshots of that project simply because there was a lot of sensitive data. And so I'm just protecting the customer's personal data. We'll talk about composite models, and then I'll demonstrate using parameterized queries, which you can use even if you're just in a regular shared capacity tenant without premium features, and then incremental refresh policies, which are a premium feature, to take that to the next level. All right, the way we were. So I'll let you think about the song title first. And we're going to talk about the way that serious BI solutions used to be, and then we'll talk about kind of where that's going in the wake of Power BI. So the way we were, of course, that's a reference to a song sung by Barbra Streisand for a movie that she co-starred in with Robert Redford of the same title. Serious BI solutions have in the past used SQL Server Analysis Services for data modeling and storing that data. And of course, we're talking about analytical data sets that are used for analytical trend reporting, the kinds of things that we typically use tools like Power BI for. So using SQL Server Analysis Services in the past, Analysis Services is installed with SQL Server onto an on-premises server. You pay for that server. You not only have to buy the hardware and manage and optimize and tune it and manage it, but there's also licensing costs associated with SQL Server outside of Power BI. And typically the person who's going to design those data models and manage those data models is a person who looks like this. They're a very technical person. It's a fairly complicated thing. It's time consuming. And these people generally work for an IT organization. That's the traditional approach. Times they are a-changin'. What's the song reference? Of course, that was a song performed by Bob Dylan in the late 60s. Visual Studio has long been the design tool of choice for serious semantic data model design. And up to as recent as a year ago, that was my recommendation, that if you've got serious data, large volume data, you need to protect that data. It needs to be a governed data set that is being managed seriously within the organization. That's typically going to be owned by IT. And they're going to design it, deploy it, manage it, and then users can connect to it. Or IT will build reports that users can use. Well, that's the way that things have been, but things are changing. Tool sets are coming together. And of course, come together is a reference from a song by the Fab Four, the Beatles. What's coming together? The features of Visual Studio, SQL Server Data Tools for Analysis Services Tabular, and Power BI Desktop are coming together. Now, it's a bit of an evolution. We're seeing features added to each of the tools, but they're definitely converging. And so we would typically use Visual Studio, the SQL Server Data Tools add-in for Visual Studio, to create tabular data models like this, but now we have these same capabilities and even more capabilities in Power BI Desktop. So Power BI Desktop is really kind of becoming the preferred tool. So that was then, but this is now. Now you'd have to have grown up in the early 80s to get this song title, but this was a song and the name of an album from a pop dance group in the 80s called ABC. And they did some great songs like Poison Arrow and When Smokey Sings. But things are changing, and we're now at a place where Power BI is moving at a very rapid pace. The development of that product is very, very quick. And that product team will focus on adding features to the product that they own and they manage, and that is Power BI Desktop. And so in order for that to be a cohesive development experience and for Power BI Desktop to be a tool that is aligned with the Power BI service, Power BI Desktop is really becoming the recommended enterprise BI development tool. Now, that's not to say that there aren't features and capabilities of SSDT and Visual Studio that may be preferable in some cases, but today, Power BI Desktop is the tool that I typically go to first before falling back on Visual Studio. So you think about that experience. We author in Desktop, we manage all of our development in Desktop, our queries, data sources, security, the data model, the calculations, and the report visuals. All of that's done in Desktop. We deploy those assets up to the cloud into workspaces in our Power BI tenant. And then peeking behind that cloud out there, that's not the sun that you see. That's actually the Analysis Services Tabular Engine. So that's right. Power BI in the service up in Azure actually has an instance of Analysis Services Tabular that manages our data models. And it's the same engine that's available when you install Analysis Services on-prem on your own server with the SQL Server install bits. And what that means is that we have access to enterprise features. They just have to be lit up through the tool sets that we're using. So what enterprise features are we talking about? Well, we're talking about direct query, which is a capability that allows you to not import data into your data model, but store metadata about tables so that when users interact with the reports, queries are generated in the native query language of the data source, whether that's SQL Server or Teradata or Oracle or whatever. And those queries are actually processed by that data platform and results are sent back to your Power BI reports. Now, there are trade-offs there, but it's still a viable and important features. Composite data models give us the ability to use the capabilities of direct query with the capabilities of imported cached tables as well. Now, because there are performance trade-offs with direct query, and when we're just generally working with data at scale, very large volumes of data, that's going to impact performance. Now, that impacts performance drastically with direct query, but it can also impact performance with imported cached tables as well. Aggregations give us a mechanism for speeding up those queries in our reports by actually storing aggregate values at different levels of grain. I'll show you what that looks like. And then incremental data refresh policies allow us to automatically generate partitions over our tables for a couple of reasons. One, so we don't have to run huge queries to reload high volumes of data. And secondly, so that we can break down the data stored for those tables so that we don't have to reload unchanged historical data sets, and we can only refresh new data and perhaps more recent data for our large tables. And then the XML endpoint. Now, as of this recording, this is still forthcoming. It's still something that we're talking about, but we know that the product team are actively working on the XMLA endpoint for Power BI, which will give us the same capabilities we have for analysis services today, so that third parties can develop tools. We can write PowerShell scripts. We can do automation. We can generate scripts. We can do all of those things against Power BI that we haven't had access to in the past, that we do have access to with analysis services. So that's really going to open up the gate for serious automation, for DevOps, for build management, for version control. A lot of those things are going to become much, much easier when we have this programmatic or semantic layer access to data models. Now, if you've attended a Microsoft event or a conference where the Microsoft product team folks have presented about Power BI recently, you've probably seen this demonstration. How is this possible that in a Power BI report we can surface 6 trillion rows of data? Most of us don't work with data sets this large, but this is an excellent example of how these new features can enable such capabilities, and we're going to talk about how that works. Before we talk about enterprise scale, let's talk about the limitations of different levels of Power BI and analysis services. Now, first of all, it's important to understand that when working with Power BI data models and analysis services, tabular data models, which technically are the same thing, that data is always compressed. And that compression ratio, the degree to which the size of your data model will be reduced, depends greatly on characteristics of your data. Correctly modeled data will allow you to achieve compression ratios of typically up to about 20x, 1/20th the size of the data sources. And typically we expect to see 5x, 10x, 20x. I've seen tables that compress to much, much smaller, up to, let's say, 50x, 100x, but that's not as usual. And these depend on characteristics like the sparsity of the data, the duplicate values, the data types, the granularity of keys. So the more sparse the data, the more duplication, the more empty values there are, and the less granular specific values are, the more that data is going to compress. So thinking about compressed data sizes, a standard shared capacity Power BI tenant will allow you to upload up to a 1 gigabyte PBIX file. That's, again, compressed data. Now, we want to reduce the size of these files as much as possible, and especially reduce the size of the file that you actually upload if we can perform a data refresh that will then expand the size of the data and making all necessary available data available, then that's better than having to refresh on your desktop and then upload large files. What if we're dealing with more data than 1 gigabytes? In Power BI Premium dedicated capacity, a premium tenant will allow you to upload and store data sets of 3 to 12 gigabytes. It depends on the level of the premium capacity subscription that you pay for each month. But the largest capacity will allow you to upload a file that is up to 10 gigabytes in size, and then when you refresh that, it can expand to up to 12 gigabytes. So that's actually a lot of data for most solutions. If you need to exceed that, though, you can use Azure Analysis Services in the cloud. So again, no hardware, nothing on-prem. It's in Azure, which means that Azure Analysis Services is a neighbor to Power BI, possibly in the same data center. So connections between that data are very, very fast. And again, depending on the service level, you can store up to 400 gigabytes of compressed data in Azure Analysis Services. On-prem, if you have Analysis Services installed on your own server, if you use SQL Server standard licensing, you're limited to 16 gigabytes per database. If you use enterprise licensing, there is no stated limit. The product itself can deal with any size data set, but you're limited just by your hardware. And you think about modern server hardware where we can have very large shared storage. Of course, memory is a limitation for the tabular engine, but modern well-equipped servers can have 1, 2, 4 terabytes of data. That's a lot of memory, terabytes of memory, and that's a lot of data. So really, virtually, there is no limit to the size of the data set that you can manage in SQL Server Analysis Services with enterprise licensing. But let's talk about how to optimize that experience. So another song reference, Blurred Lines. Of course, that refers to the dance song from Robin Thicke and Pharrell Williams, who were famously sued by the Marvin Gaye family due to copyright infringement. What do I mean by blurred lines? Well, the distinction between analysis services and Power BI are becoming blurred because Power BI uses the analysis services tabular modeling engine. In the past, we've had a subset of those features. Now we have a superset of those features, but analysis services also has features that Power BI doesn't have, which means the two really are converging feature by feature as they're being added to each of those services. But there's definitely a shift to the Power BI tool set and the Power BI service from analysis services in terms of the preferred tool. Now, I just want to cite a reference solution. This is a project that I recently finished up for a client. I'm not going to show any sensitive data here, but I did want to show the row counts of various tables. Now, these sizes have actually since increased, but you can see that we have some relatively large tables here, just shy of 5 million appointments, just over 6 million charge capture records, which is an extension of patient encounters, about 20 million test results. The largest table in this model today has about 30 million records. I actually missed the person measures right there on the bottom row that had 16 million at the time that I captured this, but that's up to about 30 million now. So in this reference solution, how did I design for scale? So there were several high volume tables that I filtered using parameters. And that was to reduce the working data set size and to reduce the size of the PBIX file. 1, to speed up development, and 2, so that it didn't take forever every time I deployed a new version of that data set file. And I just want to point out that in new Power BI projects, I separate the data set from the reports. I create 2 different PBIX files. Now, there are some minor challenges in doing that, and so actually I start with one PBIX where we manage the queries and the data model and the measures, the calculations, and the reports. But then when we get ready to transition to a true version management ALM model, I create a separate copy of the PBIX where the reports connect to a published data set, And that copy of the PBIX only has the reports in it. And you can actually copy and paste visuals from one to the other. But in the end, we only have the queries and data modeling calculations in one file and the reports in another file. That makes it a whole lot easier for users to do their own reporting as well. But the dataset PBIX file can be large, and I used parameters to reduce that size. And then we can fill that up with data when we do a full data refresh once it's been deployed to the service. So how do parameters work? Well, we define two parameters. And if you look at the documentation for the new incremental data refresh policy feature, you define two parameters called range start and range end. They have to have these names. They're case sensitive names. They have to be date time data types. Even if you're working with date only data, they must be date time in order for this feature to work correctly. Then you give them default values. So here I used a range of 1 year, January 1, 2018 through December 31, 2018. And then I imported the tables from views. Now this is key. Database professionals tend to try to solve problems in SQL, which is fine because that's a fine tool for joining tables together, creating aliases, doing groupings, doing aggregations. All of those things can be done in SQL. However, for this and many other features to work correctly in Power BI, Power BI prefers, and in some cases only works with single database objects that it perceives to be tables. Now that could be a table, it could be a view, it could be a table valued user-defined function. But as you can see here, once I've connected to the data source, I have this list of views. I actually wrote a view for every single table that I wanted to import, and then I just select those views rather than using inline SQL. So you need to select database objects from the source. Don't write any inline SQL queries. And again, I created views to consolidate database queries on the server. And we actually created a separate database just to contain the views so that we didn't have to put those views into a vendor database. And then we create a row filter step, and that's just very simple. You go to the column that is a date time data type, and this is our partition key that we want to filter on to create partitions, and just create a date filter on that column, and it must use this logic: is after or equal to range start and is before range end. And again, the column has to be date time, just as the parameters are date time. Even if you're just dealing with dates, it has to be date time. And you want to perform that filter as early in the query as possible. By query, I'm referring to the Power Query query in Power BI Desktop. And the reason that we do that is that we want the filter to get folded into the native query. So this only works with data sources that support query folding. There are many that support query folding. Query folding means that the M query in Power Query gets translated into the native query language of the data source. In this case, since we're using SQL Server, it's T-SQL. If it were Oracle, it would be PL SQL. If it were Teradata, it would use the Teradata SQL dialect, etc. And here you can see the predicate down at the bottom of this native query that I'm viewing. It says where encounter timestamp greater than or equal to, and then it translated that parameterized filter. And so the row filter generates the folded native query. And if you have steps later in your query that break query folding, there are things that transformations you might do that can actually disable query folding. That's okay, because the query's already been folded at this stage of the query, And then the results are cached in memory, and then Power Query works against that cached result set as a result of this folded filter parameterized query. Then within the data model, we define an incremental refresh policy, and that's done within the data model, not within Power Query. And it will only light up and enable you to perform these features where you have this filter in place that references this pair of parameters. So you define the period number and period type. In this case, I'm saying 5 years. If I were to say 60 months, it would generate 60 partitions instead of 5 partitions. And actually had a table that the query plan in SQL Server was so poor because so many tables were being joined together, and there were some indexing issues in SQL Server. Those queries were very, very slow, and 1 year partitions actually would time out. And so by using months instead of years, it generated a series of smaller queries that didn't time out, and it solved that data refresh problem. And then you can optionally detect changes. That's using the checkbox you see down at the bottom, detect data changes. And if you use that option, it actually prompts you to select a column in the table, such as the last update date. It's a typical timestamp type column that a database designer would use for ETL maintenance. And this will use that to detect changes and automatically refresh those changes. To cache or not to cache. Now, even though the spelling is different, this is a reference to the late, great Johnny Cash. And just for fun, imported in-memory data tables provide high performance. Okay, so this is an important learning about using the Vertipack analysis services engine, that in its most native mode, where you import data into the model, that's held in memory, and that's fast, high performance. But the trade-off is that you have to have a place in memory to put all of that data. Direct query tables, by contrast, offer scalability. So if you have massively large data at the data source, it may not be feasible to import all of that data. Now, this is often a topic of conversation in new projects, and it's important to understand that if you can import that data, that there's a lot of goodness that you get from that. If it is possible to import that data, it makes things simple, development is faster, performance is going to be good, your projects are uncomplicated, all good news. But in cases where there is a bona fide reason to use direct query to deal with data at scale, perhaps using unique data sources that deal efficiently with large volume data, that there's a lot of goodness there. So because there's such a trade-off between those two different options, now we have composite data models. These offer the best of both worlds with what we call dual mode tables and optionally predefined aggregations. So what does that look like? Well, in the past, the only option was to use one or the other, either direct query or import. You could not combine tables in both modes into a single data model. Today, we have the ability to create composite models where tables can either be direct query or imported. It's important to note that you can't take an imported table and convert it to direct query, but you can take a direct query table and convert it to import. Again, best of both worlds. It provides fast performance for cached in-memory tables, but also provides some flexibility, supporting high volume and near real-time access from data sources. Direct query has some performance trade-offs and some calculation restrictions. There are certain DAX functions that will either not be supported and not work at all, or will just perform very, very poorly because of the way that they have to handle a lot of data at aggregate. And so, there are reasons that direct query has been kind of a difficult pill to swallow in the past. aggregations allow us to mitigate some of these performance concerns. The idea behind aggregations is that we define a virtual table. We define a table in the data model that is the aggregate of values grouped by a pair of keys. So as you can see, sitting between the date and geography tables, we have this aggregate table that we're calling sales ags. And if the grain of the date table is date, 1 row per day, and the grain of the geography table is, let's say, city, then we're going to have 1 row in the sales aggregate table per date and city with grouped and pre-aggregated values. And then when a user navigates to a visual or uses a visual within the report that is grouped on date and city, they're going to get that pre-aggregated value rather than having to go back to a fact table and perform the aggregation on the fly. And if that fact table were direct query, then it's not going to have to go out and run a group by SQL query against the data source. All right, so it resolves performance issues by storing the cached aggregate results, and the aggregate tables are already rolled up at a certain level of grain. You can have multiple aggregate tables. This requires some planning and advanced design. Typically, you're going to use aggregations to solve performance problems. Perhaps with more experience, after we have years of experience with this feature, we'll be able to look at a model design and say, okay, yeah, we ought to put an aggregate table there. But today we see that there's a performance issue. Let's add some aggregations to take care of that performance problem. So here's where you design aggregations. It's a brand new feature, and so though it does work well, we don't have as much experience with this. But as you can see, we specify the columns for a table that we want to group by. This is much like a lot of user experience interfaces that we already have in Power Query and in query building tools. So we just say, I want to group by the order date, the customer, and the product subcategory, and then I want to aggregate the sales amount and the unit price using sums. All right, so you can create multiple aggregate tables. They support different levels of detail or grain. Because the aggregate values are stored in the model, it does increase the model size, but if designed well, it not significantly. And their purpose is to improve performance and mitigate the performance handicap of direct query tables. And you're not limited just to direct query, but that's a use case that's very common. Something to keep in mind is that these aggregates are stored in the model. And of course, direct query results are not stored in the model. Therefore, there is opportunity for the direct query tables and the aggregate tables to become out of sync. So refresh often and just manage expectations around that. And just know that that's a trade-off of using aggregations with direct query. Show me the way. All right, what's the song reference? I'm going to show you a picture of the group, but I'm not going to tell you who they are. What are we talking about? Well, these are our demos. So I'm going to demonstrate a couple of things. I'm going to show you query parameterization, which is not limited to premium capacity tenants. And then I'm going to show you incremental refresh policies, kind of an extension of query parameterization that is a premium feature. Show Me the Way was a great song from the group Styx in the late 70s and early 80s. All right, let's take a look at our demos. This is a Power BI project that I've created with data from an on-premises SQL Server database. This is the Contoso DW database with retail sales information. Here in Power Query, you can see that I have imported my store sales table, which is a rather large table for demonstration purposes. And I have connected to it both in import mode, where I'm importing all of that data into the data model, and then I've also connected to it using direct query. That's a really simple thing to do. If we just go to our recent sources And I'll choose my data source. Here I'll just choose a table. There I see my preview. And on this next page, I will be prompted to either import data from that table or to connect via direct query. And it remembers my last choice. That was the last thing that I actually did. So it was really that simple to get both of these tables into my model. Now, when I look at my direct query table here in Power Query, you can see that I am looking at data, but this is just a preview set of data. When I go back to the actual data model and we select that table here, you can see that it actually doesn't show me any data because there's nothing in the model. It would actually have to run a query to go fetch that data. And that's also noted down here in the bottom of the designer. Now let's take a look at the data model. Now I'm going to switch over to this view. And I'm going to right click and show the properties for this table. So here in the field properties, I've selected a table, so even though I'm in field properties, I'm looking at a table. Here you can see that the storage mode of this table is direct query. My other options are import or dual. Now, if I've already connected to a table and added it via a direct query, you can see that I can convert it to an import mode table, and I can also convert it to a dual mode table. And dual is an addition that essentially allows you to designate a direct query table that will conditionally be cached in the model. And that's for the purpose of being able to fold queries between related tables in the model where one is in direct query mode and the other might be in cached or imported mode. If we make that a dual mode table, then it can actually optimize the query between those two tables. Let's switch over to the diagram view. And here you can see that I actually have both tables in my model. And even though this table is a direct query table, this relationship right here to the order date is a relationship between a direct query table and an import mode table. So there you essentially see evidence of the composite model. Now let's go back and talk about incremental refresh and parameterization. Now, if you're not a premium Power BI user, you haven't purchased a premium subscription, probably because of the cost, that's okay. What I'm going to show you is still quite valuable. So my objective is to reduce the size of the PBIX file, reduce the size of the working data set here on my desktop so that I have a lightweight file that I can deploy to the service. And then I want to process that and get a larger volume of data. So to do that, I'm going to define a pair of parameters. So here's range start and range end. If we go to manage those parameters, you can see that that is a date time data type. And I've set default values January 1st through 12/31 of the same year. Now, my date column in this table is a date type. And I've done this a few times now. I think, oh, well, that needs to be a date time, so I'm going to go ahead and change the data type and then do my filtering on that. The filtering works just fine. Partitioning works great. But the problem is that that date column is actually related to this date column in my order date table, and that breaks my relationship, and filter propagation no longer works in the data model. So that's a problem. So I'm going to actually go back, and rather than change the data type of that column, I've actually duplicated the date column, So that created a copy of the date column, which I renamed. There you can see I called it date underscore partition key. It doesn't really matter what it's called because I'm just going to end up hiding or removing that from my query later. And then I changed the data type to date time. So there you can see that it shows midnight of every day. And you also can see the little clock there. So we can see that that is a date time data type. And then I applied my filter. So let's click on the gear so we can actually see the filter expressions. And you can see that that column value is after or equal to my range start parameter and is before range end. And it's immaterial why I use this logic. If you look at the documentation for incremental refresh policies, that's the way it works. All right, so let's go ahead and close that. Of course, it'll offer to reprocess that table since I made a change, which is fine. Now let's go back and take a look at a report. Now we need to wait for that query to run, and it loads up a few tens of thousands of rows. So you can see here in desktop, in my working set of data, I only have 1 year loaded, and that's sufficient for report design. That gives me the ability to work with enough data in order to design my measures and create my reports and test things. Now, if I were doing year-over-year variance calculations, I might need a couple of years worth of data in order to verify the results. But again, that's just for design purposes. And now I'm ready to deploy this up to the service. So let me go ahead and do that. And we'll go ahead and save my changes. Notice that the name of this is incomplete. That's because I created it for demo purposes, and I wanted to be able to complete those steps. So I'm going to put that here in the Paul's Demos folder. And while that's deploying, I'll go ahead and open a browser. All right, so there you can see the data set and the report that I have deployed. Let's take a look at the refresh properties, and here you can see that I have those two parameters. So in order to load a complete set of data now, I'm just going to expand this range. And then I can schedule a refresh. I've already configured a gateway, and so the service has connectivity to my local SQL server. If I were using Azure SQL Database, then I wouldn't need to use a gateway. And I'll just manually refresh the data from here by clicking Refresh Now. As you can see, that's running. Get the little spinny thing. It'll take a few seconds, and then that should be done. Now, this will take a little longer than it did before because I'm loading at least 3 times as much data because I happen to have 3 years worth of demo data. And I'm also loading this through the gateway, so there'll be a little bit of latency there as well. But you can see that it really didn't take that long. And now if I go back to my reports, you can see that I do have 3 years worth of data. And this is my cache data, so you can see that as I click on a location, that's very, very quick, and it's interacting with that data very, very quickly because it's with the service. Now let's contrast that with direct query. Now keep in mind that my database is down on-prem, my connection is through the gateway, we've got the internet in between. And this won't be affected, of course, by the filter that I showed before because that was on a different table. But if we click on Moscow right now, let's see how long it takes to get updated data. Not very long at all. It was really a fraction of a second, but it wasn't instantaneous like we're used to seeing. So few milliseconds to do some very simple queries in direct query mode versus just about instantaneous results when I'm not using direct query. All right, now let's implement an incremental refresh policy. I already have all of the pieces in place in Power Query, so I don't need to make any changes to my actual query. I just need to go to this table. I can right click or use the ellipsis menu and choose incremental refresh. So because I've met all of the requirements in terms of my parameters and my filter, I can just say I want to turn on an incremental refresh policy. And I would like, now remember that this is relative to when the refresh runs. So the current year is 2019. My sample data runs from 2007 to 2009. So I need to think about that. So I'm going to say I would like to get data for the past 15 years. And I want 1 year partitions. And I don't have data in the last month, but it might make sense to keep the last month of data reloaded and fresh. So I can go ahead and say, well, go ahead and give me 1 month incremental partitions for any data after the last whole year. I don't have a column in this table that would tell me when the record was last updated, but if I did, I could tell it that I wanted to detect changes and then select the appropriate column here. I'm going to go ahead and turn that off. Let's say apply all. Now, keep in mind again that I only have 1 year worth of data. Oh, there is one more thing that I wanted to show you, and that's how I manage versioning for a data set. You see this model version? I have a very simple table in my model called model version. This is driven by a parameter. So you see that this parameter called model version actually drives this table. And the table actually just goes and gets the value of this parameter right here, and it puts that in this calculated column right there. And then I also just run a little piece of M that gets the current date and time and puts that timestamp right there. And that lets me know when my data refresh last ran. So I want to increment my model version. And to do that, all I'm going to do is bump this number up. And I haven't been keeping up with my version numbers, so I'm going to skip all the way up to, let's see, a minor revision number of 5. And we'll go ahead and do a close and apply. That's going to refresh just that table, so that'll be super quick. You should see that that gets updated. That's great. And it also showed my last data refresh was right now. And now I'm going to publish my model. We'll go ahead and publish it to the same workspace as before. And I'll replace the model. And the reason that I update the version number and that I have that last data refresh column is that there's absolutely no doubt about which version of the model that I'm using, what features it supports, and whether or not it was updated. There you can see that the model version was updated. And if I go back to my data set and let's look at the refresh options again, you'll see that those date range parameters no longer show up. The incremental refresh policy absorbed them and doesn't expose them because it's going to manage those ranges itself. And it'll actually seed them with the appropriate values so that it can create multiple partitions and pass different values into those parameters automatically. It just happens. It doesn't really matter how it works because you don't have to manage it. Let's go ahead and update that again. And by the way, if you have deployed a data set that supports incremental data refresh and you've scheduled refresh on that, every time you redeploy the data model, it will automatically run a refresh cycle. Now, I had to do it manually this time, but I just want to show you that if I go back and take a look at that report, that we do in fact have all of our sample data loaded, which meant that it did actually apply the incremental refresh policy, and it performed the refresh over all of our data. At this point, if this were a live presentation, I would ask if there are questions. You are welcome to reach out to me or any of the other great folks at Pragmatic Works through these channels. And I will do my best to respond as time allows, as long as you're not trying to sell something. The Pragmatic Works blog at pragmaticworks.com/blog. My personal blog is SQLServerBI.blog. I tweet at Paul_Turley, and there's my LinkedIn profile, P. Turley. Again, if you are a contributing member of the community, I will be happy to connect with you. Thank you very much.